Let's talk about the portable grinder. You see them in pretty much every workshop, right? But here's the thing, don't ever let that small size fool you. This tool packs a serious punch, and if you don't give it the respect it deserves, it can be one of the most dangerous things you'll ever pick up. That's why today we're diving deep into the step-by-step safety inspection that can stop a disaster before it even thinks about happening. You know, a zero-accident workplace isn't about getting lucky. Not at all. It's about having a solid process. It's about building a culture where safety comes first, and that all starts long before you even plug the tool in. The foundation for all of that? A really thorough and consistent inspection.
So why all the fuss about this one tool? What makes it so dangerous? Well, it's just pure physics. Think about it. You're holding a motor that is spinning a disk at thousands of revolutions per minute. The amount of energy there is just immense. And if any little part of that system fails, especially the wheel itself, the results can be absolutely catastrophic. This inspection is all about making sure that failure never, ever happens. So here's our game plan. We're going to start with the paper trail, to make sure everyone's accountable. Then we'll move into the hands-on physical and electrical checks. After that, we'll get into the nitty-gritty of the guards and wheels. Then we'll hit the one rule you absolutely have to know, the RPM rule. And finally, we'll wrap up with the all-important final sign-off.
Okay, let's get the paperwork out of the way. And I know, it can feel like a total drag, but trust me, this part is non-negotiable. Before you even lay a finger on the tool, you have to start what we call a chain of responsibility. This isn't just about red tape. It's about making sure every single tool is tracked and that someone is accountable for its safety.
So what does that actually look like? Well, you're logging the basics. The company name, the date of the inspection, the specific make and model of the grinder, and its unique equipment number. That way we know we're talking about this specific tool. You also got to note if it's owned by the company, if it's a rental, or if it belongs to a contractor. That tells you exactly who is ultimately on the hook for its condition. All right, paperwork is done. Now we get to the hands-on part. I want you to think of this like doing a walk-around check on your car before a long road trip. You're just looking for any obvious red flags, any signs of trouble that could stop you dead in your tracks. First things first, just look at the grinder's body. See any cracks, any major damage? Then run your hand along the power cable. Any nicks, frays, or worst of all, exposed wires are an immediate no-go. Make sure it's got a proper industrial plug, not something you'd see on a lamp at home. The motor capacity should be easy to read. And here's a big one. Test that dead man switch. When you let go, it has to stop. Instantly. No excuses. And finally, check that the cord is flexible. A rigid one can break right where it enters the tool, and that's a huge risk. Okay, we've dealt with the electrical side of things. Now let's talk about the physics. We're moving on to the mechanical safety systems. These are the actual physical barriers designed to stand between you and a disc that's spinning like crazy. This is your first and maybe your most important line of defense. So, does it have a handle? You need that for control, for stability. Is the wheel guard there and locked down tight? It is not optional, so don't even think about taking it off. Take a close look at the grinding wheel itself. Any cracks or chips, even tiny ones. It has to be perfect. And when you're swapping out that wheel, you have to use the key that came with it. Don't try to improvise with other tools. That's how you damage the whole assembly and create a huge weak point. Now, here's a detail that might seem really small, but it is so important. The gap between the guard and the wheel, it cannot be more than 3 millimeters. 3. Why so specific? Well, think about it. If that wheel ever shatters, that tiny little gap is the difference between the guard doing its job and containing all those super fast fragments and those fragments becoming shrapnel. It's a tiny number with massive consequences. And here we are. We've reached what is, without a doubt, the technical climax of this whole inspection. Seriously, if you only remember one thing from all of this, make it this. This is the simple law of physics that keeps a grinding wheel from literally exploding while you're using it. Now, before we get to the rule, let's just do a quick refresher. RPM. It stands for revolutions per minute. It's just a simple way of measuring how fast something is spinning. The higher the RPM, the faster it goes, and the more force it's generating. Simple as that. Okay, and this is where it's critical, because you are always dealing with two different RPM numbers. First, you've got the motor RPM. You'll find that printed on the tool itself. That's the power. That's the speed the machine wants to run at. Then you've got the wheel RPM. That's printed on the wheel you're putting on it. That's the limit. The absolute maximum speed that specific wheel was built to handle before it fails. So here it is, the golden rule. The number on the wheel must always be higher than the number on the machine. Let me say that again. The wheel's RPM has to be higher than the motor's RPM. If it's not, you are literally telling that wheel to spin faster than it was designed to. The forces will build up and it will tear itself apart from the inside out. It's not magic, it's just physics, and getting it wrong is a recipe for disaster.
Now, while we're talking about preventing catastrophic failure, let's add one more electrical safety net to the list. The machine itself has to be either double insulated, you can look for a little symbol of a square inside another square, or it needs to be properly grounded. This just makes sure that if there's some kind of internal short, you are protected from getting a nasty electric shock.
So, we've checked the paperwork, we've checked the body, the cords, the guards, and the physics. The last piece of this whole safety puzzle, well, it isn't the machine at all, it's the person holding it. It's the human element.
This quote really just says it all. You can have a perfectly inspected, top-of-the-line tool, but if you put it in the hands of someone who isn't trained or competent, it's still an accident waiting to happen. Competence isn't just knowing how to flip the switch. It's understanding the power you're holding and respecting it. And that brings us right back to where we started, closing that loop. After going through every single one of these checks, the inspector makes the call. Is this thing fit for usage? Yes or no? Then they sign the form, putting their name on it, taking that responsibility. And finally, a supervisor reviews and countersigns it, completing that chain of accountability we talked about at the very beginning.
So I'll leave you with this to think about. Now that you've seen how a tiny 3mm gap, or a couple of numbers on a sticker, or a little frayed wire can make all the difference, what's the one detail you'll never, ever overlook on a power tool again? Because this way of thinking, this attention to detail, it applies to everything.
And hey, if you want to keep this safety-first mindset sharp, it's always a good idea to stay up to date. For more guides just like this one, you can follow Global EHS online. Stay sharp and stay safe out there.